Welcome to another installment of our classes on database development. So far, in talking about data manipulation language, DML statements of the Transact SQL language, we have camped out in the statements that allows us to read data from our database. I'm talking about the select statement. Now it is time to discuss the other DML statements to better understand how they also operate. Remember that when you work with any persistent storage like databases in any form, relational or NoSQL, you will be performing CRUD operations. CRUD, as you know, is the abbreviated form of create, read, update, and delete. In Transact SQL, DML statements facilitates CRUD also. Therefore, as a reminder, CRUD maps to the DML statements like this. Create maps to the DML insert, read to select, update is update, and delete is delete. Like I said earlier, we have spent a decent amount of time reading data from our database. Let us talk about the other DML statements in depth, including insert, update, and delete commands. We will also include the merge statement, which is a handy statement when we need to perform insert, update, delete using a single command. The insert statement is used to add one or more rows to a table or view in SQL Server. To see how to use the insert statement, we will create a new table called student in one of our practice databases. Note that the student table has an identity property on the student ID column. You will remember that an identity property on a column signifies that the column will be automatically incremented by the database engine using the seed and increment values that are in parentheses. Also note that there is a default constraint on the enrollment date column that sets that column value to the current date if a data value is not provided when data is inserted into the student table. Both of the above considerations are important when we add rows to any table. First, we will use the values clause to add one row to the student table. Note that we issued an insert into command and specified the object we are targeting. In this case, our insert operation is on the student table. The values clause takes comma-separated parameters that correspond to the columns of the table we are targeting. The column names are specified in the parentheses after the table name, also comma-separated. From the code, you will see that the only column we have not explicitly specified is the student ID column. This is because of the identity property on that column. The database engine is responsible for auto-incrementing any identity column in a table during an insert operation. Reading the data with a select statement, we see the data we just inserted in the student table. You can also use the values clause to add more than one row to a table. Each parenthesis after the values clause corresponds to a row in the table. Make sure each parenthesis except the final one is separated with a comma. For this insert, we have decided not to include the column names in the insert statement. This is valid as long as the data values in the values clause follow the same order as the column list in the table, and there is one data value for each column as in the table. If the values in the values clause are not in the same order as the columns in the table, or do not have a value for each column in that table, a column list must be used to explicitly specify the column that stores each incoming value. For this insert, the column list is explicitly specified because the values clause data value do not follow the order in the student table. Also, you see that both the middle initial and enrollment date columns were neither specified in the column list nor data values provided for them in the values clause. The middle initial is a nullable column, and the null value has been inserted when no value was specified for that column. The enrollment date column, on the other hand, has a default constraint which rightly uses the current time as the value for that column when none was specified. It is not only the values clause that is available for you to insert data values into a table. You can also use the select statement. Let's start by looking at an example where we use the select statement to insert literal values into the student table. This code shows our normal insert into command, followed by the table name and a column list. However, instead of a values clause, we are using the select keyword to insert literal values into the first and last name column. Reading the table data shows that our insert worked, even with a select clause. The fact that we can use the select statement to provide data values unlocks some interesting ways we can insert data into a table. First, we could source our data values from a different table by using the insert statement followed by the select clause in what is generally known as the insert select method. You see here that we are going to insert the first and last names of all Northwind employees in the United States to our student table. Reading the data in the student table after the last insert shows all the 5 new students from the Northwind database. Also note the sequentially incremented data value in the student ID column. This, as we know, is done automatically by the database engine based on the seed and increment values of the identity property on the student ID column. There might be times when we want to pause this identity property on a column and explicitly insert data values into that column. Let us consider a fictitious example. The AdventureWorks company has asked us to train 250 of their customers. Part of the contract states that those customers must have their AdventureWorks customer ID as their identifier in our own school system. AdventureWorks has given us temporary credentials to access their customer table. To load our student table with AdventureWorks customer IDs, we would have to override the identity property on our students table student ID column. To achieve this temporary override, we use identity underscore insert. Identity underscore insert is a session scoped property, which means we can turn it on and off in any session. In this code, we are turning identity underscore insert on, the student table on. Insert the 250 AdventureWorks customers. Note that because we are explicitly inserting data into the student ID column, it is stated in both the column list and the select list. Finally, identity insert is turned off on the table. Reading data of the student table now shows that we have 250 AdventureWorks customers enrolled in our school with their AdventureWorks customer ID as student IDs in our school system. As you can see, the insert select method of inserting data into a table can be used to bulk import data from one table to another. The insert select method of inserting data into a table requires two steps. First, you create the table, then you insert data into the table using insert select. If you want to accomplish both steps using one statement, you use the select into statement. The select into statement operates in two parts. The new table is created, and then the rows resulting from the query are inserted all in one operation. Here you see code that pretty much resembles our normal select statement, but on close inspection you will realize that the into clause is sandwiched between the select list and the from clause. The into clause signifies the table to be created, and the select query data is inserted into this table. Running this code creates the employee addresses table and inserts data into it in a single operation. If you want to create an identity property on a column in your table created with the select into statement, you can use the identity function. Here we create and load the US address table in the person schema of the AdventureWorks database using the select into method. Pay attention to the syntax of the identity function used to create an identity property on the address ID column. The identity function comes after the select keyword and takes three arguments: the data type, seed, and increment in that order. For our US address table, we are specifying an integer data type, a seed of 100, and an increment of 5. Let's read the data to confirm the person.us address table was created and loaded with data. You can see our address ID column with the specified seed and increment. Next on our list of DML statements is the delete command. The delete command is used to remove data from a table. To remove all the rows in our student table, you issue the following delete command. You write the delete keyword and you specify the table you want to target using the from clause. In our case, we want to remove all the rows from the student table. Usually, you would not be removing data from an entire table. This is why you need to ensure that your delete statement is removing the exact number of rows you actually intend to remove. Remember that computers don't do what you want them to do, they do what you told them to do. You do not want to be the developer that inadvertently deletes the entire order table in production. You can ensure your delete statement is targeting the correct number of rows by first writing a select statement reading those rows before deleting them, or you always make sure you have a where clause in your delete statement. I find in practice that a combination of these is necessary when issuing the delete command. For example, to delete a student with the last name of Swift from the student table, let's first write a select statement retrieving that student. Running this statement allows us to inspect the rows returned in order to ensure we are targeting the exact row we want to remove from the table. Once satisfied, we can issue the delete statement by replacing the select asterisk with delete. Running this statement removes the row with the last name of Swift from the student table. You can also remove rows that fall into a range. For example, delete student ID from 1 to 10. First, we read that data to be sure we are targeting the correct rows. Running this code, we see the data we will be deleting. This time, we will just comment out the select asterisk and add the delete command on top of that commented out select asterisk. This delete statement and the last one are syntactically the same since the select asterisk is ignored by the database. The advantage of using this style is that you can first check the rows you are deleting by highlighting the select part. When you run the entire code, including the delete, the commented out select asterisk is ignored. You could also be asked to remove rows based on data in another table. An example will be removing those AdventureWorks customers from the student table. We know that the student ID of the population we are targeting corresponds to the customer ID in the customers table of AdventureWorks. We can use this information to restrict our delete to just those customers. To achieve this, we could either inner join the student table to the customer table using the student ID customer ID relationship, or pass the customer ID of the AdventureWorks customers as a subquery list to the outer delete main query. From the database engine's perspective, both the join and the subquery method are treated the same in terms of execution. You will realize in both methods, we are still reserving the option of viewing the data that we are about to remove. The subquery is going to remove 251 rows, and the join is also going to remove 251 rows. What I would like to point your attention to is the delete syntax. Notice that we are referencing the table we are deleting from by its alias, in this case, S. Now, we will use either one of these two statements to effect the delete. Before we leave the delete statement, we will need to talk about another transact SQL command that we can use to remove rows from a table. This is the truncate table statement. Truncate table removes all rows from a table. It is similar to a delete statement without a where clause, but it is faster. Let us compare both the delete and truncate table. While delete is a DML command, as we have seen in our recent examples, truncate table is considered a DDL statement because underneath the hood, truncate table drops and recreates the table and resets the table's metadata. Delete is slower than truncate table because delete operation is fully logged, meaning that each deleted row is logged in the transaction log, while for truncate table, only page deallocation is logged, each row removed is not. As a result of logging each row in the transaction log, delete actions can be rolled back, while truncate table actions cannot be rolled back. Logging each row deleted takes more space, while truncate table actions do not take as much space. An important difference between the two is that while the identity property on a table is reset back to its original seed value after running a truncate table statement, identity column does not reset after delete. Finally, you can filter the rows you need to delete with a where clause, but truncate table removes every single row in a table. Let us take a closer look at the identity property reset difference between delete and truncate table. I have a script here that creates a my employees table and inserts 9 rows into the table. Notice that the employee ID has an identity property with a seed of 1 and an increment of 1. I will run this script and read the data from the table. You see the 9 rows and the auto-incremented identity column employee ID from 1 to 9. Now, I will issue a delete command on the my employees table. The 9 rows are deleted and the table is empty. Next, I will insert 1 row into the now empty my employees table and read the table data again. Notice that after reinserting a row into a previously deleted table, the employee ID identity column values continue at 10. The last deleted value from that column was 9. This means that removing rows from a table by issuing the delete command does not reset the identity property on that table to its original seed value. Now, I would repeat the whole process by dropping my employees, recreating it, and inserting our original 9 rows. Reading the data from the table shows that we are back to our original rows with employee ID from 1 to 9. Next, instead of issuing a delete command, I will issue a truncate table command to remove all the rows from the table. Note the syntax for truncate table. It is the command truncate table followed by the name of the table. I will run the code, read the data to confirm there are no rows left, then reinsert a single row and see the effect on the identity property. Truncate, read, the table is now empty, then I would reinsert the same single row and then read the data in that table again. You see that this time, unlike delete, the employee ID's identity property was reset to the original seed value of 1. This distinction between delete and truncate table dictates when you should use either one when removing rows. Obviously, if you do not want to remove every single row from a table, then the only option is to use the delete with a where clause for your filter condition. Our next DML statement is the update statement. The update command is used to modify, that is, change one or more column values on an already existing row of data. There will be times when you will need to change data values in your table or view. Your student name might change, your customer addresses changes, you need to change the price of certain products. All these are examples where you will need to use the update statement to modify data. I will use the student table and data from AdventureWorks to demonstrate a few update examples. Let's look at the syntax for the update statement by assuming that the enrollment date has been pushed forward by 10 days. We need to implement this change in the database with an update statement. The update statement begins with the update command, followed by the name of the table you are targeting. After the table name, you use the set keyword to specify the column you are making a change in. In our case, we want to modify the enrollment date column, so the set keyword is written with this column name. After that comes the equal sign and the new value we are assigning to the stated column in the set keyword. Here we are using the dateAdd function to add 10 days to the current enrollment date in the student table. If I execute this statement, I will be changing the enrollment date for all the students in the table. While this is what I want to do, odds are that you will not be updating every single row of the tables you will be working with. Your data modification should be able to target either a single row or a subset of rows in your target table based on a criteria using the where clause. Before we do that, I will run the code and see all the enrollment date pushed ahead by 10 days. You can modify a single row, for example, change the last name of the student named Wanda from Vernon to Mayland. Everything about this syntax is the same with the earlier update statement, except we now have a filter using the where clause to return just the row we need to modify. Let's run this code. The message window says 2 rows affected. I thought we were modifying the data for just one person. This brings me to my next point. Just like the delete command, it is always a good idea to read the data we are about to modify before running the update command to avoid inadvertently modifying the wrong row. Also, as much as possible, your filter should use the primary key field of your target table if the table has a primary key field. This is important because the primary key, as we know, is guaranteed to be unique. You can also modify more than one column in a table. An example is if you need to change the last name of a student named Looney to Cooper, and also change this student's enrollment date to a year from now. This requirement modifies 2 columns for the same student. As recommended, we first read this data to ensure we will be modifying the correct student's data. The data shows that there are 2 students with that last name, but by making further inquiries, we discovered that the student we need the modification on is student ID 39. We need to rewrite our query to read the correct student. By using the primary key of the student table as our filter criteria, we are certain that we will be targeting a single row as specified in our requirement. Now it's time to write the update statement. You can see that this syntax is based on the select statement. Like our deletes, we have commented out the select part, aliased our student table, and layered the update statement on top of the select statement. Now, the update command references our table alias, and the set statement specifies both columns we are modifying with a comma separating both of them. This syntax has the advantage of letting us read our modification before and after the modification. Before modification, we run our update statement. Now, after the modification, last name is now Cooper and the enrollment date is changed to a year from now. You do not have to explicitly specify the new data value in update statements as we have been doing. You can get the new values from data in other tables. We will consider an example where we used another table to set the context of the modification. For this example, the school management has decided that the modified date in the customer table will be each student's enrollment date. This means our task is to modify the enrollment date of each student to the modified date in the customer table corresponding to their student ID. Here, we are changing the enrollment date to the modified date in the customer table. Now, each student has the modified date in the customers table as their enrollment date. There are times when you will need to update table rows in batches. An example is when you are making updates to very large tables. In this situation, you can use the top clause with your update. Here, we are using the top clause to limit the amount of rows updated in a batch. Pay attention to the update syntax with a top clause. The batches could be done in a loop. We start with 250 rows. We issue the first batch of 10. By the time we check with our select statement, we are now down to 240 rows, and we can take another batch and check with our select statement. It's now 230 rows, and we can keep running this batch. Assuming this was a large table, our top could be top 100, top 1000, and we can put this in a loop, put a delay of about 10 seconds depending on our environment, and this could run the updates in batches. If you think about what you are actually doing whenever you update a column, you will realize that you are replacing an old value with a new one. In essence, you are deleting the old value and inserting the new value. This is what an update is behind the scene. It is a delete followed by an insert. Remember this as we progress in our discussion of DML statements. We have discussed the insert, update, and delete data manipulation language statements in Transact SQL language. At the very least, try out all the examples on your own, type out the code by yourself, push yourself further by designing a customer table, practice inserting 1 row, 2 rows, 5 rows, bulk load the table using either Northwind or AdventureWorks databases, delete based on a criteria, delete the entire table, reload with your earlier script, and practice modifying data in the table. Be a database developer that writes code. If you have any question, reach out. In our next episode, we will look at the output clause and spend some time learning how to perform insert, update, and delete operation using one statement, the merge statement. Remember, keep practicing solving problems to gain more understanding of what you are learning.